going to have properties of lane ranging from 0 to 5. It's going to have the position, travel down the highway, the speed in miles per hour, the combined fuel economy, the total emissions, and its color. And along with this class, we're going to have a couple constants we'll use. We'll have the max speed a car should go on the highway, the minimum speed the car should go on the highway, the minimum lane the car should be in, the max lane the car should be in, the minimum position it should be in down the highway, and the max position because the highway ranges from 0 to 100. Now we're going to move on to the constructor. The constructor just outlines how each car is built. It has 4 arguments taken in. The first if statement just checks to make sure that 4 arguments are given when creating the car class. If 4 arguments are not given, it should create a random car. We take in the type, start lane, position, and speed. The object.speed, which is the car, will be set to the speed given in. The lane will be set to the start lane it's in. The position will be set to the start position along the highway. Now we compare the string type to either Honda or Volkswagen. And based on this choice, we'll either set the combined fuel economy to the Honda or the Volkswagen and the emission to either the Honda or the Volkswagen. We have some basic functions for manipulating the car properties. We have the move function, which given an increment in time, will move the car a certain length down the highway. We'll also have various functions for varying the speed of the car in order to make the car more random. And we increment the speed, decrease the speed along the highway. But lastly, the function we have, get position, will return the lane the car is in and the position the car is in down the highway. So a highway is a system of organizing the car objects to make it more easy to manipulate and to add some artificial intelligence to the cars on the highway. So we're going to have several properties in this class. We're going to have DT, meaning the change in real time. It'll be in hours. The speed limit of the highway, which will be like the time the cars trend around. The number of cars, the time, will be like the real time elapsed in this project. The sim time will be how long it took to simulate the project in this class. The CO2 will be the CO2 emitted total in grams. Consumption is the rate of fuel consumption at any time. And list will be the list of cars in the class. Cycle count just keeps track of the cycles gone through in this class. We have the constructor. The constructor takes in 0 arguments, and that is because every highway is going to be uniform at the start when we run the GUI, and if we want to manipulate any of these, we will call functions. We start off with cycle count equaling 0, the speed limit 65, a typical highway, the number of cars 20, that's given. Sim time, CO2 are all 0 because that's their starting value, and DT is 0.01 hours. Moving along, we have the main function in this code, which is cycle. What cycle does is it goes through each car, updates position, makes sure it's within the max speed, min speed, calculates the CO2 emitted by the car and adds it to the total, calculates the instantaneous fuel consumption by the car, adds it to the total, and then it runs through a couple AI programs. It does that for every car, and then after it's done, it adds up the total sim time, the total time, and by then it will have accumulated the amount of CO2 in grams and the instantaneous fuel consumption. Now to explain the AI functions, we use check front and check back as the main AI functions. What check front does, we can see it down here. Check front checks if there's a car within 2 car lengths in front of it. If there is, it checks the speed of the car in front of it. If it's going too slow, of course we want to pass this car, so we check the sides. We have another function over here for checking the sides. What this does is it checks if a car is in 3 car lengths on either side, or if there is even a lane open on either side of the car. If there is, it returns true for each the left and the right lane. Now going back up to the check front. If the left lane is open, we'll get in the left lane and speed up so we can pass the car. The right lane is open and we didn't choose the left lane because the left lane is the fast lane and is preferred. We'll get in the right lane and then speed up and pass this car. If not, our only option is to slow down so that there is no collision with this car. Check back is similar. What it does is it checks if there's a car behind you trying to pass you but going faster than you. If there is, then it will get in the right lane if it's open. If not, it will speed up just enough so that there is no collision. There's also populate function and several other functions for grabbing values in this class. Populate, all that does is sets up the cars, 10 Volkswagens and 10 Hondas by default, and it varies the speed a little bit to add a little bit of randomness to simulate real life because real drivers are not always uniform. Change time is a function for changing the increment of time in order to speed up or slow down the rate of real time elapsed in the program. There's also grab CO2, which returns the total CO2 emitted, and that will be used for displaying in the GUI. There's grab consumption, which grabs the fuel consumption, same thing. And reset will automatically set all the properties back to the default outlined in the constructor. And that's all of our methods.
I will be explaining the GUI function for you. So this is our GUI function, and here's where it begins. This is where it's initially executed. So within our traffic sim opening function, we have 3 different axes which represent 3 different images. First 2 represent our 2 cars, a Volkswagen and a Honda. The images, as you can see over here, are not exactly Volkswagens or Hondas, but they're just different colors of different cars to represent on the road as a legend. And here we have our highway. So initially our user data is going to be equal to 1, and this is going to be used for our start-stop function. So here is our start function. When we press start, we create an instance of the class and we populate the highway. So once we press start, the user data becomes 0 and the button start turns into stop. And once we press stop to stop the program, the user data becomes 1 and the button becomes start. So let me show you a quick demo of that. So here I'm going to click start and the button is going to become stop. And here is our program. As you can see in our program, we have the rate of fuel consumption, we have real-time elapsed, we have simulation time, and we have CO2 accumulation, along with our cars, our visual representation of cars on our axis that's running. Real time shows the real time that is elapsed, and rate of fuel consumption shows the amount of fuel that's been consumed by the cars on the highway. The number is really high due to the fact that we're covering a long distance of road in such a short period of time. Here's a simulation time, which is how long the simulation has gone for, and they're in different units. And this is our CO2 accumulation amount, which is how much CO2 has been accumulated by all of the cars cumulatively on the highway. Here we initialize our highway cycle, and for our first 10 cars, which consist of the Volkswagen species, we find out the lane and the position on the highway by using the getPosition function. And we plot this on an axis and use square markers as the cars. The green over here represents the Volkswagen and the red over here represents the Honda. And we have our axes from 0 to 100 and 0 to 6 representing 5 different lanes in between. And over here we have our handles.realtime, handles.simtime, handles.accumulation, and handles.rate. All these do is display the corresponding values in our display screen right over here when the start button is pressed. And the rest of the callbacks don't really have any code in them because the start function is the most important one. So yeah, that's pretty much it.
I'm also going to explain some of the bugs that we had to debug and possible improvements that we can make. Furthermore, we could possibly improve our code by having the cars change lanes. So if you notice when the code is being run, the cars are basically just going across, and as you can see right here, there's like a clump of cars kind of connected to each other. But if we were able to run our artificial intelligence code that we had written in the highway class, then it would basically show that the cars right before they make contact would basically go around each other, and then it would be more realistic that way.